All right, today's 7th hour video is brought to you by Izzy. Izzy, say something on the mic.
Hey.
Wow. That was tremendous. Okay, I'm sure they will not forget the video now. All right, here we go. Rational expression, simplify the following. You guys know that 54 and 24 are both divisible by what number? 6. So if I take out a 6 on the top and the bottom, and then how many x's do they share in common? So I have x in the top and I have x in the bottom, okay? And what remains is I have 9x in the top, and what do I have in the bottom? 4. Now, you don't have to write it like this every time, but I just want you to understand what the heck you're doing when you work through the situation. 6x divided by 6x is 1. And so when we talk about things like canceling or going away, the fact is 6x divided by 6x is 1. It's still there. It's just 1 times anything is itself. So you can see in this situation we get 9x over 4. So just careful when you just like start slashing things that you understand what that actually means. Okay? All right. Rach, you know where we're at? Keep turning. You're doing the homework. We're going to go notes. It's okay. It's okay. You're kind of a part-time student right now. It's all right. We're going right there. There you go. Look at that. Good thing you're by Ava. She's so helpful. Okay, letter B. You got the x minus 3 and the x minus 3. Those do divide, making 1. And 8x squared divided by 4 is going to be 2x squared. So today is day 1 of dealing with fractions. Tomorrow we're going to deal with complex fractions, a little bit more challenging. Okay, Friday you get a work day. Don't write this down, but watch me go for letter C. Okay, 5x over 10x squared. Let's see, 5 over 10, that's going to be 1/2. Looks like I'm going to get an x in the denominator. Minus, and that's going to be a 1/2. Looks like I got an x as well, so that makes 0. Woo! Kind of convincing, right? Not even a little convincing? I mean, it's so illegal, but I thought it looked pretty smooth along the way. In order to start like canceling things out, you have to factor it. So what can you factor out of the top? 5 times x minus 4. What can you factor out of the bottom? 10x, and you were left with x minus 4. Now you can cancel them because x minus 4 divided by x minus 4 is 1. So it's the same factor in the top and the bottom. You're left with 1 over 2x. Letter D, I would like to slash the x squareds right away. Totally illegal. Stop doing it. I factored to x plus 3 and x minus 3. The bottom factor is 2. Good. X minus 2 and x minus 3. Notice the x minus 3's do divide to make 1. And so we're left with x plus 3 divided by x minus 2. All right, so how would you check your answer on the test? Here's how I always check my answer. I would just take a number. I'm gonna take 1. What's 1 squared? Minus 9. So negative 8 up top, and I plug in 1, and I get 1 minus 5 is negative 4. Negative 4 plus 6. Dos, which is Spanish for 2. Let's see if I get the same thing down here. I plug in 1. 1 plus 3, 4, and 1 minus 2. Are those the same? Yeah, they are. That gives me confidence that I'm probably right. I just plugged a number into my algebraic expression. But the fact is it takes time. And some people are like, I don't want to waste so much time. What else are you going to do? Here we go. Multiply the following rational expressions. We do not cross multiply here. If you have, say, 2 over 3 is equal to, say, x over 15, that's cross multiply where you have an equal sign. There's no equal sign here. But you can do something that may be called, say, cross cancel. So, for example, 3 over 9 reduces to 1, 3. And 4x over 2x reduces to 2 over 1. Now multiply those, you can see you get 2 over 3. So when you were multiplying rational expressions, you can look across from each other and cancel things. Just like x plus 2 divided by x plus 2 makes 1. And 4 over 12 makes 1/3. Notice you still have an x minus 1 in the top. So if you multiply that, you get x minus 1 over 3. What should I do for letter C? Factor them. Very good. So the x plus 5 does not factor, nor does the 3x plus 1. But does 9x plus 3 factor? Yeah, take out that 3 and you get 3x plus 1. And x squared minus 25? X plus 5, x minus 5. Obviously, the x plus 5s reduced to 1. And the 3x plus 1s reduced to 1. What are you left with in the top? And at the bottom, piece of cake upside down. Try next one on your own. Yo. In this situation, I treat it as the difference of two squares. So x squared minus y squared, right? So I did x minus y and x plus y. Now instead of x, we have a plus b, right? So it's a plus b minus, and then y is a minus b. Yep. Yep, and you're going to see something will cancel. Hi.
So, would that not be, is it not supposed to be a 6?
The x's are gone.
Okay.
X divided by x is 1. Okay, looks like the x minus 2's do in fact cancel. The x plus 3's do in fact cancel, and I get x minus 1 over x plus 1. We all good? Questions? Question going once, going twice, 3 times. I cut my hair yesterday. Nobody noticed. Thank you. Do you know how much work this takes on a given day? Yeah.
How much earlier do you wake up by
5:30.
Oh my gosh.
Yep. Yep.
Yep.
Anyway, okay. Enough of that. Enough of that. When you're dividing two fractions, what do? Instead of dividing two fractions, we multiply by the reciprocal. Sweet. So I've got 2x over 3 times 12 over 6x squared. Okay, so we multiply by the reciprocal. And we multiply by the reciprocal, it's easy to see that 12 over 3 is 4 over 1. Great, so those are gone. And then I've got 2x over 6x squared. Good, so I did my kind of cross cancel, if we want to call it that. I don't really have a name for it. We have 4 over 3x. Now, sometimes you have larger algebraic expressions. This is already factored for you. We have x minus 2 times x plus 2 over x plus 1. And now I'm going to multiply, and I just write the reciprocal. X times x plus 1 over x minus 2. What cancels? Yep. And notice that instead of having something in the numerator and something in the denominator, we have two things that sit in the numerator, don't we? So in the numerator, we have x times x plus 2. Done and done. That's the answer. Okay, flip it over. We got a little bit left. Again, it says divided by. I multiply by the reciprocal, so it's times that x squared minus 9 over x plus 1. Now, sometimes you guys just go ahead and you write your factors up there, and that's fine, but sometimes people get lost here. I'm going to write the whole thing down. X plus 1 times x minus 1 over x plus 3. X minus 3 times x plus 3 over x plus 1. Trust the process. Looking for anything to cancel. Looks like the 1's cancel and the plus 3's cancel. I have that quantity that remains. X minus 1 times x plus 3. Whoop, x minus 3, excuse me. Letter D on your own. Go. Glance up when you're done, see if you got the right answer. Ava, what's the speed of our serve right now? 110? So, Jordan laughed. She doesn't believe you. She says it's only 106. 106. Oh, the one? That better? What did I do now? There's 3 now? Yep, I think I'm right now. Yep, alright. Yep, small mistake. My apologies. I get 3 a year. Alright, how about this? Every time I make a mistake, I'll give you guys $1. Every time you make a mistake, you give me $1.
It's kind of your job.
Imagine if I got paid by the like percent correct and incorrect. I mean, I just choose easy problems then. Okay, here we go. In order to add or subtract rational expressions, you must have common denominators. Here I don't have a common denominator, so I'm going to multiply the top and bottom by 2. And when I do that, I get 6x minus 10 over 6 plus 8x minus 1 over 6. Now they have common denominators. I get 14x minus 11 all over 6. Easy peasy. Letter B, you see that instead of a number in the denominator, I have an expression that involves a variable. I will simply combine the top to be a 2x minus 3 all over x plus 4. In the bottom, letter C, you can see that they are almost the same. In order to make them the same, I can just subtract 1 from the top and the bottom. No, you can't do that. Or just think about that. Think if you had, like, say, 5 over 7, and you're going to add that to, say, I don't know, 5 over 6. You're like, well, 7 is almost like 6, so I'll just subtract 1 from each. So now we got 4, 6 plus 5, 6. You know what I mean? Like, that's kind of what you're trying to do. But you know that you can't do that, can you? In fact, in order to make them common denominators, we have to multiply this side by x over x, and this side by x minus 1 over x minus 1. We get a 2x squared over x times x minus 1. And then we get 3x minus 3 over x times x minus 1. They now have common denominators. I can make the numerators one numerator instead of 2x squared plus 3x minus 3, all over x times x minus 1. A question came up during first hour, does the top factor? It's harder to see if something factors if there's a 2 in front, right? I'll show you an easy way to see if this factors. Remember the AC method? So if you take a times c, we get x squared plus 3x minus 6. Does that factor? No. So if this does not factor, then this doesn't either. Okay? There are no numbers that multiply to negative 6 that add to positive 3. So we're done with that. Last one. Similar approach, multiply top and bottom by x squared minus 4. I don't got to do that. Why not? Are you telling me that x squared minus 4 has an x plus 2 in it? Isn't that handy? So therefore, since there's already an x plus 2 in this, I just need to multiply this over here by x minus 2 over x minus 2. That makes the problem a little bit more reasonable. And so I have 5 over x plus 2 times x minus 2. And then I'll distribute the 6 minus 6x minus 12 all over x plus 2, x minus 2. Notice I was careful with my subtraction sign. I didn't distribute negative 6, I distributed the positive 6. But now as I subtract, I should distribute the negative, correct? So will it be a positive 6x or a negative 6x? So negative 6x, and will it be 5 minus 12 or 5 plus 12? So I get 17 all over x plus 2, x minus 2. And that's that. That is the easy part of rational expressions. The more challenging part comes tomorrow when we see complex. You have the rest of the hour, which is 22 minutes. Not too bad. 21 minutes to work on whatever you want. You're ready now to work through that 1.4 first worksheet. I will come around and answer whatever questions I can. I've got 1, 2, and 3. Go. Let me quick stop my video.